Welcome back. So as part of this video, my intention is that we set up a sandbox environment for you wherein you can run your experiments. And not only that, we'll also discuss about like the basic anatomy of a C program. How a C program is to be written, what are the essential conditions for it, how to go about compiling it. And the idea behind that is so that, as we progress through other sections, you can, in the meantime, explore the web, learn more about C language, and be able to run your own experiments, right? So that is the intention, to enable you with the basics that can allow you to start doing experiments. All right, so what do we have on the screen? Well, first off, the sandbox is essentially a repository, and that repository is available at github.com/pajamabra/c-language. Once you type that and land on a page, this is the page that you'll see, like whatever you see on the screen right now. But this is the name of the repository. You should see something like this. Now the files listed here can vary because this is the first video and this is like just the initialized repository. By the end of the entire recording for this course, this directory would have evolved, right? But irrespective of what you see here in the directory, this is what you're after. This URL is what you're after. Okay, once you've landed here, then I would invite you to kind of explore this code button right here, right? And we're going to first carry out some steps, and while the environment gets prepared, I'm going to explain what all is going on as part of creating that environment. Okay, so click here and then you'll see these two tabs, local and code spaces. So we are going to go to code spaces, and you can either click here to create a code space on main being the branch, and we'll talk about that much later, or you can click this green button, create code space on main. So click on either of these, and let me just go ahead and click on this. A new tab opens, and what's happening here is a code space is getting created, and while it gets created, I'm going to walk you through what is happening. So we had a browser window, and Chrome was my browser. I recommend using Chrome because I'm trying it out on Chrome, and Chrome is quite stable to handle all of this. Then we went on to a repository, and we clicked the create code space, right? Code space or code spaces, right? And what is that? So this is a virtual machine. It's actually a virtual cloud machine. So you can imagine it to be a machine that's in the cloud, and this cloud virtual machine is hosted by GitHub, right? And to be able to do all of this, please ensure that you're logged into your GitHub account, and then you're reaching out to the URL, because you are required to sign in for the code spaces to be able to be created by GitHub. Okay, so what is this virtual cloud machine then? So it's essentially a Linux machine, right? And we'll shortly see that. So this Linux machine has certain tools that let you compile your code, right? And also it's independent of which laptop you're using. So we wanted to kind of decouple which laptop you're using, because the installation steps for build tools and all differ. We didn't want to go there. So this is a very nice uniform environment that everyone can have access to, and everyone can try out their experiment. Okay, so this code space essentially is a Linux machine, and this Linux machine opens up like VS Code. It looks like VS Code. So we have some files here, we have a terminal here, and we have the editing area here, right? So we can edit our files here, the files will show up somewhere here, and we can run some terminal commands here, the command line commands, right? So this essentially is a view of the Linux machine. We have the terminal, we have the file system, and we have the editor area, and that's what is required, right? Going forward, we'll also discuss as to how you can do all of this locally, right? So that you don't have to depend on a cloud machine. You can do it on your own computer if you'd want to. But this is the gist of what CodeSpaces is. And then let me go back and show you how the environment is. Let me bring myself here. So yeah, as you can see, we have a VS Code type of window here, right? And this is like the editor area. This is the terminal, and this is where the files will be listed. And the files here initially will be the same as that in the repository. You can go ahead and add more files, right, as you do your experiments, and that's what we'll see also. Now, an important thing is all the file menu is available here, and let me quickly show you that. Except I can, yeah, okay. So if you see, file menu is available here, the terminal menu is available here. So in case you don't see the terminal at the bottom, you can go ahead, go to the burger icon here, from the menu, terminal, new terminal, right? And it will spawn. Now the interesting bit is this terminal, the path here is same path as here. So C language, right? And the files here are the files available here. So let me show you that. If I type ls, which is for list the content of the current directory, you'll see it says readme, which is same as this. All right. So now this is the first time that we have launched this environment. As you run your experiments, you'll need to close the environment, relaunch it, and so on and so forth. So first things first, the name of my code space is this, the light rate space sniffle, right? And this name is different for different code spaces. Your code space might have a different name, and that is completely okay, right? And the same thing shows up here also. The reason this is important becomes clear in a bit. Again, I must reiterate, we're doing all of this to create a sandbox environment where you can run your experiments, right? So that is the key, that is the part we are wanting to nail in this video. Okay, so let me then first tell you how to go about closing this environment. So all you have to do is simply close the tab and the environment is done. The machine will be shut down and all of that will be taken care of. Okay, and then next time when you want to, go back to that working environment, all you have to do is revisit this URL, the repository. Again, be sure that you're signed into your GitHub, account. Then go to code, and within code spaces, you will see the name of the code space that was created earlier, right? And so this is the one that is for me. So now what I need to do is click on the active, or this might change also. It's active for me, it might be inactive for you, so that doesn't matter. Go down here and then click on open in browser. And the moment you click on that, it kind of again opens up the same code space environment. So this is how you kind of, close it after an experiment is done and reopen it when you want to come back to it. And if you'll see, it restores back the status or the state that we had left it at. Perfect. So if all of this is understood, we are, halfway through. And now let me guide you on how to go about writing a C program, what are the basics of it, and how you can kind of self-navigate. Okay, so all we need is a file that ends in an extension .c, right? Again, so I'll just call mine as piyush.c. It can be any name. Typically, people like to write their program in a main.c file. So that's usually where the entry point is. So when you're looking at an app that's written in C, or a utility or a program that's written in C, people usually hunt for the main.c because that's where the program starts. So if you're reading somebody else's code, looking for main.c is it's a good idea. Okay, so we have created main.c here. Again, the way I created it was I just hovered here, this icon showed up, the file plus, it says new file. I just clicked on it and it created like this prompt to enter the file name. I entered piyush.c, later modified it to main.c. And once I click on that, it's available in the editor window here. What I'm going to do is kind of increase the font size and the screen size. The other thing I want to do is maybe put this entire thing in full screen. And right, so we have like the entire screen to ourselves. Perfect. So how do we go about writing, or what is the anatomy of a C program? Now, C is a language that you can think of is built as recipes and sub-recipes. Okay, what does that mean? So it means that you group instructions together, right? Group instructions together, and some of the kind of um, line of code can also instruct on calling another group of instructions, right? So we have to kind of group things together. That's the idea, group the instructions together. So that's one of the ways in which you should always think about. And for those reasons, C is called a functional programming language, right? And I'm saying functional from the standpoint that this group of instructions, when they are clubbed together, this entire bunch is called a function. And you will kind of in future videos see me referring to this keyword called function. But function essentially you can just imagine as uh, you know instructions grouped together. All right. So if that idea is clear, then what happens is in a C program, because we want to group instructions together, we must have a function. And the function that the C program starts with usually, and this is also very important, I'm saying usually because as we'll see in the future, it's not always the case, doesn't have to be always the case, but usually the function where the execution starts from is called main, right? And that's why I'm naming it as main. Again, this is just introduction, so don't uh, sweat too much if you're not understanding what all is going on here. Take my word for it, trust me, and in few videos you will understand what's going on. All right, okay. So a typical structure of a C program looks like this. There is a function, it has a name, that name typically is main, right? And we call main as the entry point. And you see opening and open and close parenthesis here. Sometimes you might see stuff in between the parentheses that will come to also later. Typically, you might see a keyword like void or int here. And then you will see open and closing curly braces, right? So the way to understand this is a function that should be clear. This will come back to in a bit. This will come back to in a bit. But the curly braces are essentially kind of suggesting to the compiler, and what a compiler is, we'll come to that also, but it is a hint, it is a suggestion or a marker for the compiler to say, hey, anything that's between opening and closing curly braces is actually those bunch of instructions that can be referred to in the name of the function, right? So anytime, let's say I'm executing the function main, what I'm really doing is going ahead and executing the instruction or the syntax, the C code syntax, which is listed within or grouped together between the opening and the closing curly brace, right? So as you now explore the C programs in some open source repository or some blog online, do look for opening and closing curly braces. Do look for you know some name before the opening and closing parenthesis, and then there would be some keyword like void, int, char, float, things like that you'll typically see. So my point here is everything, all instructions are grouped within a function, right? And the function here happens to be called main, and then there is like opening and closing braces, parenthesis, and then there is something called a return type. In this case, it's void, and then there is closing and opening curly braces. Opening and closing curly braces are just a way of indicating that anything between those is set of instructions referred to by the name main. All right. So we have written this much. Now, how do we go about compiling? So what is compiling first off? I briefly hinted at the keyword compiling. Compiling essentially means, okay, let's take this text and convert it to, binary or machine code. And what machine code is, what binary is, we'll discuss in a lot more depth. But what this essentially means is zeros and ones. And this zeros and ones is what we submit to the CPU somehow to be executed. Right? So this process of going from text all the way to binary at a high level is called compiling, and compiling has various stages, which we'll discuss also. But compiling essentially means go from text to machine code. Umbrella term. And one of the compilers is GCC. It's a utility. And what it does is reads this file, the code within it, and converts it into the machine code. So next, what we're going to do is compile this code. So the compilation happens this way. We say, okay, hey GCC, what we would want you to do is take main.c and compile it. Right? So consume main.c and give us the binary. And all you have to do is just say GCC space main.c. Right? And if I had let the name of this file be piyush.c, then you simply say GCC space piyush.c. Okay. When we hit the return key, you can maybe go back in the video and see that earlier we only had main.c and readme.md, but now we have a.out. So what GCC does is it takes main.c and it generates the binary or machine code, right? But then this file needs to be called something. So it calls it a.out, just a default name. And this happens to be the name on Linux and Unix based systems. So Mac would generate a.out also. I'm not too familiar with how GCC does it on Windows, but I'm expecting it would do the same thing. All right, so a.out is available. And now how do we go about executing a.out? So we will just simply do /, which means in my current directory, I would want you to execute a.out. Right? So that's it, /a.out. Nothing exciting here. And when we hit the return key, nothing happens, right? And at least visually nothing happened. But what really happened behind the scene was the operating system, in this case Linux, consumed a.out, read through the program, and the CPU executed it. Right? The CPU was given the binary instructions a.out, whatever was within a.out, the binary. The CPU read that, executed it. Because there are no instructions listed here, nothing was executed. Okay. All right. Fair. Hopefully, what's so far clear to you is what main means, what the curly braces mean. The parentheses will come to later. These keywords we hinted at, void, int, char, all of that. We'll discuss a lot more about this later. Let me just give you a hint at what the keyword at this place is usually referred to as. It's referred to as the return type. What return means, what type means, we'll talk about it later. But now let's do something useful with the program, right? So what I'm going to do is I'm wanting to do the classic hello world. And so I'm going to say include right, and introduce a new line. The syntax will come to that in a bit. And then I'm going to say printf, curly braces, hello world, and then provide /n. And then I'm going to repeat this process of gcc space main.c, and I'm going to also repeat the, the, the command execution of ./a.out. And you see that hello world is now printed on the screen. So something functionally happened, some useful stuff happened. Not very useful, but some useful stuff happened. All right. So what is this? Right now, let's tease it apart. There is something called hash include, right? And then there is something called stdio.h. And then there are like triangular brackets or the angled brackets. So this line here essentially is telling the C compiler, which is GCC in our case, that hey GCC, we are going to call another recipe. So recall that I told in C, we group instructions into a recipe called function. And one of the instructions within a recipe can be, hey, call another recipe or execute another sub recipe, right? And this recipe is called printf, right? Print formatted string is what it means. And how I came to know about it, we'll come to that later, but just trust me that the main program is essentially, or the main function essentially, is saying, hey, I'm going to request another function to execute. And execute what? So printf, I'll call it function again, it's a recipe, and this recipe knows how to print things on the terminal, how to submit characters to the terminal, right? The input output, so to speak. Again, if you don't understand any of the keywords, don't worry about it. It'll be repeated so many times that eventually you'll remember it, and also in due time you'll understand the significance. So you notice here that there is an opening and closing parenthesis also, right? And then we have done, or rather we have the string within those brackets. And then at the end we have a semicolon. And it's ultra important to remember that a, a expression in C, or a line in C delimits or ends in semicolon, right? Again, let's not dive too much into the details of this. You'll eventually accept and understand this also. But any expression usually ends with a semicolon, right? Any line of code in C ends with semicolon. Now you could argue about, hey, this is not ending in semicolon, and that is correct, because once we have opening and closing brackets, then the idea is that the expressions would be within the curly braces, and each expression ends in a semicolon, right? Fair. If so far, let's just do a revision. So we know this is a function, function's name is main, the parenthesis we'll get to, this is called the return type, we'll get to that also. Curly braces suggests that the 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 recipe, the instructions for the recipe called main are listed within the curly brackets. So the recipe happens to be, hey, call another, or execute another recipe called printf, and that recipe within the brackets is taking in, or there is something there, but the expression ends in semicolon, right? So look for semicolons, look for open, close brackets, curly brackets, and parentheses. Look for names like main, printf, or something on the left of the parenthesis, opening parenthesis. Then there is return type. This we did not talk about. We'll talk about that in a bit. But what is this hello world here? So it turns out that you can submit some input to a recipe, right? And the recipe in this case is printf, uh, printf, right? So that input is to be provided within the parenthesis, opening and closing parenthesis. And what it means here is main takes, right now at least, main takes no inputs. That is what it means. Printf, however, can take an input of a string, a formatted string we call it, but let's get into the formatting part much later. This the string is what we are providing. And hello world is the string, and the string is always in double quotes. And the last /n that you see here, that stands for the character new line. So one of the experiments you can run is don't include the /n and see what happens. Okay. So we are then essentially saying, hey printf, I want you to execute the recipe of printing to the screen, and oh, by the way, print the string hello world. So that is essentially what is happening. So what have we learned so far? We have learned something about functions. Main is a function, printf is a function. And we kind of also touched upon this fact that a C program typically, usually, starts with main function. In open source code, you will find main.c somewhere, and within that, usually you will have main as the function, as a convention. But usually the program starts at main. It's not a precondition that all the programs should start at main. Fair? Then we talked about curly braces, we talked about what printf is, we talked about void. And now let's talk about this last piece here, which is what does the include and the angular bracket means. It simply means this. Hey, I have not given you details about the printf recipe, how to go about already doing it. But it's already available as part of something called the standard library. And a library is essentially collection of recipes, right? So we say, hey, GCC, as you're reading through this file, I'm wanting you to go ahead and include the standard library functions, right? So that's what stdio.h means. .h stands for header. It's an extension to denote that, header is where the information about the recipe is. So printf, the details about printf can be inferred or found from stdio.h. So the standard input output library is what we would want you to compile our code with. So behind the scene, main.c gets kind of, compiled, yes, but standard library is also getting compiled and getting included. Again, if this was like a mouthful and too much to digest, trust me, we'll decipher all of this in videos to come. But here's the angular brackets simply mean look at the standard installation location. And what is that standard installation location? Oh, GCC has certain standard locations on the system, certain paths that it will go look for the standard library. So that's all the angular brackets mean. Look for stdio.h and the library code at standard locations. And this hash include essentially is called a directive, so to speak. And the directive is hinting GCC, hey, I want you to go ahead and look for stdio.h or stdio library and include that code when you're generating the binary, right? So the final code here is main.c plus the standard library. And that's about it. So this is how we went ahead and created a simple program. What you will, this entire thing was just to kind of make you aware of this fact that you will see this pattern and this pattern repeated over and over in a lot of source codes. So the anatomy of a C program is there has to be a file that ends in the extension C, and you can actually go ahead and play around with the extensions also, see what happens. And the typical structure is there is a function and then there is instructions as part of the function, right? And so hopefully now when you browse around, the C code would feel a little familiar, and in the future, as we go through the future videos, the familiarity will just increase, and hopefully you feel more and more comfortable. All right, with this, you're good to go. Try out your experiments, go through some blogs, try experiments and see what comes out. All right, with this, I'll see you in the next one.